All right, so we're going to do your study guide today for your quiz this week. And problem number 1, identify the choice that best completes the statement or answers the question, what is element A23? Remember, that's row and column. All right, row 2, column 3. So we go down to row 2, which is right here, and column 3, which is right here. And in row 2, column 3, we get a -7. So -7. Row, column, when they're asking you to identify an element. And in problem number 2, how can you represent the system of equations with a matrix? All right, first equation is in alphabetical order, no missing constants or no missing coefficients. Second equation, you've got an x and a y, no missing coefficients. So we're going to go -11, -15, line 2, and 7, -15, +2, and -11, -15, -11, -11, -15, 2, 7. All right, so answer choice A. Remember, you're just rewriting these equations without the variables, and you're using this vertical line to represent the equal sign. If there are variables missing, okay, be sure to use a 0 in that variable's position relative to the other equations. All right, then number 3 asks you, what linear system of equations does the matrix represent? So if we were to rewrite this in equation form, we would have a 9x minus 11y equal to -2, and then a -14x plus 11y equal to +8. And then it's just a matter of matching, and be careful when you're matching. So 9x minus 11y equals -2, -14x plus 11y equals 8, so answer choice C. All right, problem number 4. You are asked to solve the system by graphing. All right, so if we solve this by graphing, we've got our xy axis. We've got y is less than -3x minus 1. So -3x minus 1 hits the y-axis at -1. It has a slope of -3, so we would go up 1, 2, 3, and to the left 1, and then another 3 and to the left 1. So we would get a rough graph that looks something like this. And it's less than or equal to, so we're shading the bottom portion of this graph. So we would shade everything down here. The second equation that you have to graph here, y is greater than 3x minus 2. So we go to -2 on the y-axis. That's where the line is going to hit the y-axis. There's your y-intercept. And from here, we would go up 3 over 1, up 3 over 1. Now, this is greater than, so it's just a dashed line. So we're going through here with a dashed line. And we would shade the top of that line. All right? So if you can see where the shaded regions are going to intersect, they're going to intersect in this area here, below the first line and to the left of the second line. So in here is where all the solutions lie for that system of equations. All right, problem number 5. We've got x greater than -2 and y x greater than or equal to -2, y is greater than +3. So we're just going to graph both of those lines. Here's our x-axis, here's our y-axis. All right, greater than or equal to -2 on the x-axis. So we go to -2. It's a vertical line through -2. It's everything greater than -2, greater than or equal to -2. So it's all of this out here to the right that would get shaded. And then when we graph y is greater than 3, greater than 3 would be at 3 on the y-axis. And that is a horizontal line through 3 on the y-axis. And we would shade everything above it. All right? So where the shaded regions would intersect would be in this upper right quadrant of where the two lines intersect. So when my pen comes back, all the solutions are going to be up in this area right here. All right, problem number 6. Greater than, y is greater than or equal to -3x minus 4. So let's graph that. So we're somewhere around here. All right, y greater than or equal to -3x minus 4. So it hits the y-axis at -4. It's got a slope of -3, so we're going to rise 3, run 1, rise 3, run 1. It's greater than or equal to, so it's a solid line. And we're going to shade the top of the line, so that would be everything out here. The second line is less than or equal to 1/3 x plus 1. So we go to +1 on the y-axis, put a point. Our slope is 1/3, so we rise 1 and run 1, 2, 3. Rise 1, run 1, 2, 3. Is also a solid line. We would be shading below the line because it's less than or equal to. So everything down here, and you can see that this region, everything in this region would be where the shaded areas overlap each other. So that's where all of your solutions lie. All right, that would be in the lower right-hand quadrant of where the two lines intersect. Yes?
The lines are straight and not like
Straight or dashed. Okay, do you see the or equal to symbol? If it's or equal to, then your lines are solid. If it's just the less than or just the greater than, then your lines are dashed. So in the case of number 5, I actually, the y is greater than 3. That should have been a dashed line. If it's or equal to, it's a solid line. If it's just greater than or less than, it's a dashed line. All right, we got 2 more problems here. Now, you can solve these systems any way you desire, meaning elimination or substitution. It's up to you. Okay? But I'm looking at this first equation. We've got 3 variables. So the technique was to label the equations, equation 1, 2, and 3. And then we were going to pair up equations 1 and 2, and then we're going to pair up equations 2 and 3. So when I pair up equation 1 and 2, I'm actually, before I pair them up, I'm going to look here, and I see that if I combine these 2 equations, I won't eliminate a variable, will I? So I'm going to manipulate them now. I'm going to multiply the top equation. I'm going to multiply equation 1 by negative 2, because that'll give me a negative 2x, and equation 2 already has a positive 2x, and that'll allow me to eliminate the x's. So when I do that, I get negative 2x minus 6y minus 2z is equal to 12, and then 2x plus y plus 3z is equal to negative 4. And then we combine those equations and we get equation number 4. The x's go away and we get negative 5y plus z is equal to 12 minus 4 would be 8. And then I'm going to pair up equation 2 and equation 3. And I need to eliminate the x's again. So I'm going to multiply now. I'm going to multiply this second equation by 3 and the equation number 3 by 2. And that will give me a positive 6x and a negative 6x. So equation 2 multiplied by 3 gives us 6x plus 3y plus 9z equal to negative 12. And then equation 3 multiplied by 2 would give us a negative 6x minus 6y minus 6z equal to 12. And that's equation 5. So when we combine those, the x's go away. We get negative 3y plus 3z that is equal to 0. So then we combine equations 4 and 5. And when we combine equations 4 and 5, you can see that we won't have any opposites in front of the variables. So I'm going to multiply equation 4 by negative 3, so that I'll have a negative 3z here to combine with this positive 3z. So if I take this equation, times it by negative 3 now, our new equation 4 is 15y minus 3z equals negative 24. And then negative 3y plus 3z is equal to 0. And we can add these two equations together. So we're going to get a 12y that's equal to negative 24. Divide both sides by 12, and y equals negative 2. So we've got our first variable. And if y is equal to negative 2, we can go back to any equation that has just two variables, and substitute. So I'm going to go back right here and do negative 3 times negative 2 plus 3z equals 0. 6 plus 3z would equal 0. Subtract 6 from each side. 3z equals negative 6, and then divide by 3. So our z is equal to negative 2. So we've got a z equal to negative 2 and a y that's equal to negative 2. And now we've got to go back to an equation that has three variables in it. And I'm going to go back to that first equation. It looks like the simplest one to substitute the z and the y into. So let's see when I do that. We're going to get x plus 3 times y, which is negative 2, plus z, which is also negative 2, is equal to negative 6. And then we solve that equation for x. So x minus 6 minus 2 equals negative 6. X minus 8 equals negative 6. And then add 8 to each side. So x equals 2. So we go back to your solution for problem number 7 would be x2, y negative 2, and z is also negative 2. All right, and finally in number 8, they tell you what z is equal to in the question. If they tell you what one of the variables is equal to, then just substitute it in the other two equations. I'll mark this equation 1 and equation 3. So if we substitute the 5 right here, we would get 2x minus y plus 5 equals negative 4. Subtract 5 from each side. And we would get 2x minus y equals negative 9. If we do the same thing in this third equation, All right. If I just substitute this, we got negative 2x plus 3y. Now, minus, this would be minus 5 equals negative 10. So add 5 to each side. And we get negative 2x plus 3y equals 5. So I'm going to bring that equation down here with this equation 1. So this was equation 1 after substituted. This would be equation 3 after the substitution. And we get negative 2x plus 3y equals 5. So look, we can just combine these equations and the x will go away. So negative y plus 3y, we get a 2y that's equal to negative 4. Divide both sides by 2, and our y is equal to negative 2. So we've got a z, and now we've got the y, and we can go back to either of these equations, the modified 1 or modified 3, and substitute. So right here, we can do 2x minus negative 2 equals negative 9. So that would be 2x plus 2 equals negative 9. Subtract 2 from each side. So 2x equals negative 11, and then divide both sides by 2. So we get an x that's equal to negative 5.5. So for problem number 8, your solution would be x negative 5.5, y is negative 2, and your z was given, that's at positive 5. All right, so that completes your study guide for your next quiz.